All right, guys, so we're going to start going over this and see how you did on your warm-up. One thing that helps me when I'm using this formula is just to rewrite this one. Some of you are doing fine, like you don't need to rewrite it, but writing it as a column just helps me see the 1, 2, and 3 of them. Okay, so for this one, I just like literally have to substitute in V2 times W3 minus V3 times W2. So I'm like literally just pulling the numbers from here. So what I have is 0 times -1 minus -5 times -2. And -5 times 3 minus 2 times -1. And 2 times -2 minus 0 times 3. All right, did I make any mistakes in my calculation so far? Did you guys see anything different? Does it look like what you wrote? Okay. All right, so then you can do this in 1 step or 2. I'm going to do 2 steps. 0 minus 10, -15 plus 2, and -4 minus 0. So I get -10, -13, and -4. So are there any questions on using that vector product formula? Okay. All right, and then I have to still find the magnitude. So the magnitude is going to be that formula that's very much like the distance formula. It's going to be the square root of -10 squared plus -13 squared plus -4 squared. And I get the square root of 285. Okay, but these are a lot of little calculations. So if you're getting something different from me, check and see, is my calculation wrong or is yours? And if it's mine, let me know, because we want to let everybody know. You got the same thing? Anybody else get the same thing? Thank you. All right, so this would be our exact answer, but if it asked for 3 sig figs, then we could round it to 16.9. Okay, so now we're actually trying to find the same thing. I get that this question is like, what are you trying to find? You're still trying to find the magnitude of the vector product, so we're still trying to find this, but we're going to be using this formula this time, and we'll see if we get the same thing. So this is what we're trying to find. So that's our variable. We're just going to work on this side. The magnitude of V will be 2 squared plus 0 squared plus -5 squared. And then that's times the magnitude of W, 3 squared plus -2 squared plus -1 squared. Remember that when you square a negative, it turns positive, and so if you're not sure if your calculator is doing the right thing, you can always just square the positive number. Take a little shortcut there, and then you don't even need the parentheses on it. And then that's going to be sine, and the angle measurement is 1 radian. So what mode should you be in? Radian, yeah. So type that in your calculator if you haven't yet. Okay, so make sure you're in radian mode, we said. And we're going to get about 16.955, which to 3 sig figs would be 17.0. So they're about the same. Like, they should be the same, but they're just 2 formulas that are going to give you about the right number. So if you had the right steps and you did it this way, or you had the right steps and you did it this way, then they would have to give you credit for this answer with this method and for this answer with this method. Okay? Right, so if you did the first method, you wouldn't put 17.0 because this rounds to 16.9. Yeah. All right. The area of a parallelogram is pretty easy because the operation that we're going to do when you have two vectors is something that we just did, which is vector multiplication. So given a parallelogram with two adjacent sides, what's another word for adjacent? Or another phrase for adjacent? If two things are adjacent, they are what? Next to. They're next to each other, okay? So adjacent means next to each other. So a parallelogram with two adjacent sides formed by vectors v and w, the area, is equal to the magnitude of the vector product, which is like what we just did. So if you did the warm-up, you know how to find the area of a parallelogram from its adjacent vectors. Okay. So this area formula is given to you in the formula book, okay? Make sure you have that so I can turn the page. All right, now think about a triangle that is formed by two vectors. Given a triangle with two sides formed by the vectors v and w, the area is equal to half the magnitude of the vector product. And try to picture that because it makes perfect sense. Okay. So if I had like v and I had w, then I could have a parallelogram, right? And they would have an area. And if I made a triangle with v and w, you see how that would be half the area of the parallelogram? Yeah. Okay, so that part makes perfect sense, but it's not in your formula book. So that's something that you just need to remember, that a triangle is half a parallelogram, okay? So 1/2 the magnitude of the vector product. Okay. I would like you to quietly see how far you can get in problem 1. You're going to start by finding the vectors for AB and AD. Then you're going to find the magnitude of the vector product to find the area. And then let's see if you can find angle ABC. You might not remember how to do all of that right now, and that's okay. I do want you to work quietly so people around you are testing. And if you need me to check part of it so that you can move forward, I can do that as I walk around. All right, guys, let's see how you're doing. All right, vector AB, 3 minus 2, 9 minus 3, 4 minus 0. Okay, questions on that one? So remember, vector AB will get you from A to B, and this is your procedure here. Yeah, go ahead.
So the first one, it's like the second one and the third one for AB, and then minus the third one for the second one. So what does that
So
mean?
you're thinking about vector product. Right now we're just finding vectors.
Oh,
Yeah, so it's not so complicated. Yeah. So right now we started with points, and we're getting a vector that would take us from point A to point B. So if you want to check and see if you did it right, go back to point A and then add the vector. Does it get you to point B? Okay. Other questions about finding vectors A, B, and AD? Okay. To find the area of the parallelogram, you should be doing your vector product. Okay, so I'm getting 35.1 square units. And I'm going to pause there for a minute because I can see some people are still catching up. Make sure that you are taking notes, that you're getting this. To find angle ABC, remember ABC, the vertex of that angle would be B. We're going to use this formula, vector product of V times W, magnitude over magnitude V, magnitude W equals sine theta. But that formula is going to give us the sine of the angle between the two vectors, which is angle A. Okay? So theta is angle A, BAD. So we're going to find angle BAD first, and then we can use the properties of a parallelogram to find angle ABC. All right, so we already know that the magnitude of the vector product of V and W is 35.1, but instead of using that rounded version, I'm going to use the square root of 1,229. Okay, and then I need to find the magnitude of V. And I don't think I've done that yet, have I? No. So that would be AB. So let's find the magnitude of AB. So that would be the square root of 1 squared plus 6 squared plus 4 squared. And then the magnitude of W. Square root of 4 squared plus, I'm just going to put 5 squared because we know that's the same as negative 5 squared, and then plus 2 squared. All right, so 36 plus 16, 46, 52, 53. You guys getting root 53 for that?
Good.
Okay. 1229 over square root of 53. And then this one is going to be 25 plus 16, so 41 plus 4, I'm getting 45, is equal to sine theta. So we're going to do the inverse sine of all of this, and this time what mode do we want to be in? We're going to be in degree mode, right. So go to degree mode, and put in inverse sine of all that. Okay, and I'm going to put it in my calculator on the screen too, so we can see how that looks. In my denominator, I might need an extra set of parentheses here. Just depends on what kind of calculator you have. This one's a little bit older. 53. Times square root 45. And then I'll have to close 2 sets of parentheses. Alright, so I'm getting 45.9, which is not, oh yes it is, that's what they got. 45.9. Anybody else get 45.9 for that? Okay. All right, but we're not quite done, because that's not the angle we wanted to find. Okay. Oh, you can't see that. Let's minimize this. Okay, so we got 45.9, and that's for angle BAD, but we want this one right here. So what is the relationship between these two adjacent angles in the parallelogram?
180 minus 1.9 equals 11.
Yeah, they're supplementary, yeah. So you can subtract 45.9 from 180 to find the measure of angle ABC. Point one? Oh, 134 because of the 3 sig figs, you're right. Okay, so that's your final answer. You might want to box it up because we got a lot going on there. All right, it's a little bit to digest there. What kind of questions do you have? You guys notice that these formulas aren't really new, right? Okay.
My question is, would it be okay for, like, to multiply the two, like, denominator roots before?
Yeah, you could. If you do that, you might want to save that value so that you can put that exact number back in and not have to round it. Yeah.
'Cause, like, what I did was I multiplied like 53 times 45, and then I was looking
Okay,
at
and that does work, yeah.
And then I grouped that, but put it as the denominator.
Yeah, that works for sure. Okay. All right. Yes. You can. I'm about to talk about bearings, so be fast. Anything else? Okay. Bearings. So you might remember in previous units we had bearings questions and we pretty much just skipped over them because we hadn't talked about bearings. IB uses bearings starting from the north. So that's different from your unit circle, which starts from the east and it goes counterclockwise. Bearings start from the north and they go clockwise. That is not the same way that other classes in the US do bearings. Like if you go to college and you take calculus and they talk about bearings, you might see a bearing that's like north 10 degrees west. And that just means starting from the north, do 10 degrees towards the west. It's not hard to figure out though, so doing bearings with this system will still help you in doing bearings, when you go to another class. It's just that they look different. Like if you take pre-calculus next year, you'll probably do bearings questions and they just look a little bit different, but you'll still be able to figure it out. All right, so in IB, a bearing is an angle that is measured clockwise from the north. And then it says the diagram on the left shows a bearing of 127 degrees. So you'll notice starting from the north, that's 127 degrees. And the diagram on the right shows the bearings of the major compass directions. So starting here at 0, and then you can see going around 45, 90. So like those numbers, you've seen them on the unit circle, but in different places, because you're just going a different direction. You have a different starting place too. All right, any questions about where you start your bearings from? All right. Bearings make perfect sense when they're centered in the middle, but then once things get off track, they can be a little bit confusing. To find the angle of the bearing, you can use inverse tangent because you'll notice that the y-coordinate here is going to be your opposite and the x-coordinate is going to be your adjacent. So tangent is opposite over adjacent, so that's what you're going to use to find the angle in a vector. Let's see. So the angle of the vector is inverse tangent b over a. The bearing is then found as an angle clockwise from the north. So for example, if this here was 40 degrees, then my entire bearing would be 90 plus 40 degrees would be 130 degrees. Because it's starting here and then going all the way around. So this one they're telling you is actually 53 degrees. And so then the bearing was 90 plus 53 degrees to get to 143. To find the vector given the bearing, you're going to need to draw a picture and determine the quadrant. And then you will find the I component with the absolute value of A times cosine theta, and then the J coordinate, absolute value of A, not absolute value, I'm sorry guys, I'm like tripping over my words, magnitude of A cosine theta. You know what, I think this one is absolute value, because I was talking with Ms. Young about this problem. Let's find out when we go through it, okay? If this one's absolute value or magnitude, but I'm pretty sure this is absolute value, because A is just a number. Yeah, let's look at it and see. All right, okay. An explorer travels 5 kilometers due south. So in this picture, here's your 5 kilometers. And then he travels 6 kilometers on a bearing of 100 degrees. Okay, I'm gonna use, I don't even have a pencil, but I'll use my erasable pen here. Just to sketch in. Use something erasable because these pictures, you're going to be drawing a lot in them. And you may decide that you have too many lines after a while. So I'm going to draw this horizontal line so that I can see that this is my 90 degrees right here. And if I have a bearing of 100 degrees, it's 90 degrees plus 10 degrees. So this one in here is 10 degrees. Okay, so I just drew a horizontal line so that I could see the 90 degrees and the 10 degrees. All right, so first we have to calculate the total distance he's traveled. So we're just trying to find this dotted line right here. And we can actually use law of cosines for this. Do you guys remember law of cosines? Most of you were here. X squared, put in x right here, is equal to 5 squared plus 6 squared minus 2 times a times b cosine c, which is this whole angle 110 degrees. No, 100 degrees, sorry. 100 degrees is the angle. Okay. So what we're going to do is we're going to put all this into the calculator, and then we'll just square root it to find x. Okay, so for x squared, I'm getting 71.4, but I want to use all those values when I square root it. So you can usually do square root, second, square root, and then second, and then the negative sign to use your last answer. You guys have other ways of doing that too. But that way I didn't have to give up any of my decimal places. And so I'm getting 8.45 for my 3 sig figs. Okay, and we do have a unit here. What's our unit? All right, any questions on that one? That was just law of cosines, cosine rule. Okay. All right, so this one is done, but now we have to find the bearing that he has to travel. We want to find this bearing, okay? And when we find this bearing, you know that we want to find it as an angle from the north, going all the way around like that. And so what we need to do is we need to find some other angles to do that. All right. The first thing we're going to do is we are going to try to find the angle that is down here, right here. Okay. So we're going to try to find that angle. We can give it a letter. I can call this like ABC. So I'm trying to find the measure of angle C. And we can use the sine rule for this. So the sine rule says, I know now that this is 8.45, so I can do sine 100 over, it's not x, it's 8.45, equals the sine of C, angle C down here, over 5. Okay, so take a moment to solve that one for angle C, and we'll fill that one in. All right, so when I isolate angle C in this one, and I end up doing inverse sine, I get 35.6. Anybody else getting 35.6? Okay, so angle C is 35.6. But that's not exactly what we need either, okay? So this one in here, angle C is 35.6. I'm gonna label that one. I get that it's hard to see. I'm gonna have to do that. Okay. I'm gonna freeze that for just a moment so that it stops moving in and out. So 35.6 is that angle C down there. And then the next thing we're gonna find is if you consider this triangle down here now. Oh, yep. Just refroze. Okay, if you consider this triangle down here now, we can find this angle in here. So we have a 10 degree and we have a 35.6. So we'll subtract those from 180 and we'll find this angle right here. And I could really use another color. I'll try this one. Okay. So I have 180 minus 10 minus 35.6 equals 134.4. And that is going to be this angle in here. 134.4 is that angle there. Inside the triangle.
Do you have three significant figures where it could be 134?
It would be, yeah, but I'm going to say that with this decimal place because I think the other angles are going to need it. Okay. So then I'm going to find this angle in here. So this is 134.4. This angle is a linear pair with 134.4. So it's 180 minus 134.4, which is 45.6. And we're almost to the angle we really want. Almost there. The one we really want is down here. And the reason why that one's going to be helpful is because it's next to this north-south line. The north-south line is the reference point that we want. So finally, what we want is, I'll use blue here. We want this angle right here. This is the one. Because here's my north, right? And so I want to find this angle in here for my bearing. So this is my north. So I want to find that angle. All right, so that angle is going to be, I've got 90 degrees, 45 degrees, and this one, I need to find this one. Yeah. Wait and check your answer. 180 minus 90 minus 45.6, and I get 44.4. Okay, that one right there. But remember that when you do your bearing, it's from the north going clockwise. All right, so basically I have to subtract that angle from 360 now. And I'll finally have my bearing. Now we're going to go to the 3 sig figs. So I'm getting, I think it was 315.6, so I'm getting 316 as my 3 sig figs. I'm going to pause there. Oh, you can't even see that last part. There you go. Write the following displacement as a column vector in unit vector form. So basically we're just trying to find the vector for this displacement. 15 meters on a bearing of 130 degrees. So draw your north, south, east, west. And remember that we're starting from the north. So we need to go 130 degrees. So that would be 90 plus 30 more. No, 40 more. Okay. So it's 90 plus 40 more. And then you're going to draw a triangle that goes straight up to the x-axis and draw that right angle. So when you do a problem like this, always connect the end of your vector to the x-axis with a right angle. We're going to put 15 here. All right, can we just do a little bit of right triangle trig to find x and y here? We're given an angle, and we're given the hypotenuse, right? It's easy, right? How much is this angle in here? It's 40. Do you guys see that? Because the entire bearing was 130, but 90 of the degrees is out here. So inside here, I've got an angle of 40 degrees. Okay, so this angle is 40 degrees. So you could set up sine of 40 is y over 15, cosine of 40 is x over 15, and that is all perfectly acceptable. Or you can use these formulas here. So the I component is absolute value of a cosine theta, and j is absolute value of a sine theta. And now it's very clear that we're talking about absolute value. Okay. So if I want to say sine is opposite, so if I want to say the y, it could be 15 sine 40. Or I could have set that up as sine 40 is equal to y over 15, which if I set it up this way, it would just go back to this way. Okay? So this one you can put right into your calculator. And then we're going to do the x. 15 cosine 40. You done? Oops. So you guys didn't get a negative yet, right? There's actually two ways that you could get the negative. One is you could just realize that your answer has to be negative because it's going down. Or two, because in the unit circle, this would be a negative 40 degrees going down this way, you could just do the sine of negative 40 degrees. The cosine of negative 40 degrees will turn out to be a positive number, and the sine of cosine negative 40 degrees will turn out to be a negative number. But either way, looking at the picture, you have to realize going to the right is positive, going down is negative, and make your answer for y negative. Okay? Even if you get a positive out of your formula, which in this case I would, if I did 15 sine 40, it's going to give me a positive number. You have to make it negative because going down is negative. So then you're going to write your vector as 11.5, negative 9.64. And then in unit vector form, it would be 11.5 I minus 9.64 j. So it says both as a column vector and in unit vector form. Okay. Does this look like something you've done in physics? Anybody taking physics? Yeah? Does it look familiar? I kind of wonder how like our notations and methods will be similar to physics and different. We'll see. Physics. I like physics because physics is just applied math. All right, guys, let's quiet down so you can hear this last part. A particle is subjected to a force of 36, I think the N is newtons, is that right?
Yeah.
All right. Acting at an angle of 25 degrees above the horizontal. So that would be this one, 36 newtons, 25 degrees above the horizontal. And a second force at an angle of 17 degrees below the horizontal. And we don't know, that just has a variable force. We don't know the force, okay? There's also resistive force of 50 newtons that is acting horizontally on the particle. And this information can be seen in the diagram below. Given that the resultant horizontal force acting on the particle is 0 newtons, find the value of F. So, each of these forces has a horizontal and a vertical component. And so you can kind of imagine that by drawing the triangles. So I've got a triangle here. And then here I've got a triangle. Okay? And what we do know is that the horizontal force is 0. So that means that if I add the horizontal force from this one to the horizontal force in this one, it's going to be equal to 50 newtons because I've got 50 newtons going left, and that means I have 50 newtons going right as well. All right, so force 1 in the horizontal would be 36 cosine, if you have to, 25. And I'll put it in. Okay, so 36 cosine, 25 for the horizontal, and then for the vertical, 36 sine 25. And then force 2, I'm going to do it over here so I can use this space for working. Force 2. We don't know the force, so we're just going to call it F. So it would be F cosine, and I'm going to use negative 17 because it went down. This is just another way to get that negative in there. And F sine of negative 17. Okay, so we know that if we add these two forces together, that the horizontal forces are going to equal 50. So we're just going to use the horizontal parts. So I'm going to say 36 cosine 25. That's this one. Plus F cosine of negative 17 is equal to 50. And I can solve this now for F. So take a moment on your calculator to solve that equation. Okay, when you put that in your calculator, you should get about 18.2 newtons for F. Anybody else get 18.2 newtons? What'd you get? Same thing?
Yeah.
Okay. All right. Guys, if you don't like writing your vectors this way as 36 cosine 25, you can always find those numbers by basically doing those cosines, right? So for the force 1, we said 36 cosine 25. I'm just saying that this x part right here, you can find that by doing cosine 25 is equal to x over 36. 36 is the hypotenuse. So I'm just doing right triangle trig. So you could just get a number here. And the same for this one. You could say sine of 25 is equal to y over 36. And you could solve this one for a number. So even though they look different, because we're using the formulas that are from over here, we're using these formulas right here. It's really the same thing as the right triangle trig that you've done all the way back since geometry class. All right, show that the vertical component of the resultant force is 9.9. So now we know what F is. We know F is 18.2. newtons. So you can put that in your picture, and then we can use that to find the vertical component of the resultant force. So for this one, it would be 36 sine 25. And then for this one, it would be, instead of F, I'm going to put in 18.2. Sine of negative 17. Okay, and when you add them up, you should get approximately 9.9. So double check that, make sure you get that. All right, anybody getting 9.9? One person, two people, three people, good. All right. 9.9 newtons.